students, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss definition terminology of Module 3 in Analog and Digital Communication course. So already we know that terminology means some technical words what are used in this module and some definitions are seen in this Module 3. Now coming to the Module 3, Module 3 is covering digital modulation techniques. So Module 3 is covered by Course Outcome 3, and Course Outcome 3 states illustrate the concept of pulse modulation schemes, demodulation, sampling, quantization, and coding for obtaining of digital data. Okay, so we are cover some definitions and terminology terms in Module 3. So, define pulse modulation. The first definition is define pulse modulation. So, pulse modulation is a form of signal modulation where the message information is encoded in the amplitude of series of signal pulses. Okay, pulse modulation can be PAM, PWM, PPM. Here, pulse modulation again two types. One is analog pulse and digital pulse. In analog pulse, PAM, PWM, PPM will come. Whereas in digital pulse, we're having PCM, DM, DPCM, ADM, like we're going to cover. Okay. So, whereas in previous session, we are covered modulation, amplitude modulation, angle modulation. You see, now pulse modulation. Okay, so the pulse modulation is a form of signal modulation where the message information is encoded in the amplitude of series of signal pulses. Okay, here the amplitude in pulses form. So that's why the name is pulse modulation. Now, what is PAM? Pulse amplitude modulation. By varying the amplitude of the pulses in proportion to the instantaneous value of the analog signal. Here, analog signal means the message signal. Here, the amplitude of the pulses. Here, my carrier is pulse, not continuous waveform. So, that is the difference. For analog modulation, pulse modulation, here carrier is analog in analog modulation. Okay. Whereas pulse modulation, the carrier is pulse form, not analog. Okay. So PAM means by varying the amplitude of the pulses in proportion to the instantaneous value of the analog signal. And another we can say, in analog communication, both carrier and message are analog form. Whereas in pulse, message is analog form, carrier is in pulse form. Okay. Now what is a PPM? By varying the position of the pulses in proportion to the instantaneous value of the analog signal. Here, the pulse position is varying. Whereas in amplitude of the pulses is varying in proportion to the instantaneous value of the analog signal. So having amplitude, width, position. So which characteristic is varying according to the instantaneous value of the message signal, we can call such type of modulation simply. Now what is PWM? Here by varying the width of the pulses, the carrier, here the width of the pulses, which pulse? Carrier pulse. The carrier signal having the pulse. The carrier signal is in the form of pulse. The width of the pulse is varying in proportional to the instantaneous value of the message signal. Okay. So here one characteristic is going to varying, the remaining two are constants. Here we are following the message signal amplitude, then the remaining two phase and frequency are kept constant. So this is PWM. Now what is communication? Communication is simply the act of transferring information from one place to another, or one person to another, or one group to another, what it may be. So communication is nothing but transferring of information. So transferring information from one place to another place or exchange of information between 2 points is called communication. So the communication may be analog communication or digital communication. Here the information is sending in analog form, so you can call it as analog communication. Here the communication is done in digital, then simply you can call it as digital communication. Okay. Now, what is analog modulation? Analog modulation refers to the process of transferring an analog baseband signal like an audio or TV signal over a higher frequency signal such as a radio frequency band. This is analog modulation. So already we've seen that analog modulation, amplitude, frequency modulation. So these are come under analog modulation. Okay. So once again, analog modulation refers to the process of transferring an analog baseband signal. Here analog baseband means analog message signal over a high frequency. What is the high frequency? Is nothing but carrier. So one is message, another is carrier. So this process is called modulation. So here both are in analog form. Then you can call it as simply analog modulation. Now what is transmission bandwidth? Transmission bandwidth is the actual width of the transfer signal or message signal. So this is varying from one modulation to another modulation. For example, amplitude modulation, frequency modulation. So they have different transmission bandwidths. Again in AM we're having a DSBSC, SSBSC and VSB, vertical sideband. So different techniques having different bandwidths. Define bitrate. Bitrate is the rate at which a signal is modulated. It is a function of symbol rate. So it is called bitrate. At what rate the signal is modulated, simply you can call. Bitrate is the rate at which a signal is modulated. Define quantization error. The difference between an input value and its quantized value is called quantization error. Here there is a difference between the input value and its quantized value. After quantization we get the quantized value. So now we are comparing the input value to the quantized value. So there is any deviation, that you can call as quantization error. Now define bandwidth. Bandwidth is defined as a range within a band of frequencies or wavelengths. So difference between high cutoff frequency to low cutoff frequency. That is also called as bandwidth. Now explain quantization in PCM. So first, what is a PCM? Here PCM is a method of converting an analog into digital signal, an analog signal into digital signal. So the value that is a signal has in certain time is called sample. So the process of taking samples is called quantization by time. Here, what is the difference between the analog and digital? So in analog, both the message and carrier are in analog form. But in digital, we are going to sample, quantization, encoding, then it converts into digital form. So here we can see how analog signal is converted into digital one. So here first analog signal into discrete form first, then it converts into digital. So how analog signal is converted into discrete? So one operation is sampling. So sampling which converts the continuous time into discrete time, but the amplitude is continuous. So after sampling we are getting continuous amplitude discrete time, but it is not the pure form of discrete. So for the pure form of discrete, we are use another operation is quantization. This is quantization. So the quantization is a process which convert the continuous amplitude to discrete amplitude. After quantization, the signal is pure discrete form. For the discrete signal, we are going to encoding or simply coding. Then it is converted into digital one. Now it is the digital signal. So how varieties of systems are there, analog to digital. One is a PCM, DEM, DPCM, ADM. So these are the different digital systems which are going to convert analog to digital form. Okay. Now state sampling theorem. A continuous time signal can be represented in its samples and can be recovered back when sampling frequency Fs is greater than equal to 2fm. Fs is greater than equal to 2fm. That is twice of the highest frequency component of the message signal. Here Fs greater than equal to 2fm. Here Fs is the sampling frequency. Fm is the frequency component of the message signal. So double or twice the highest frequency component of the message signal. So this is sampling theorem. By using sampling theorem, or according to sampling theorem, we are going to convert an analog signal into discrete time signal. Okay. Next, define single polarity in PAM, pulse amplitude modulation. So single polarity PAM is a situation where a suitable fixed DC bias is added to the signal to ensure that all pulses are positive. Only single polarity. That polarity is positive polarity. So that is single polarity PAM. Double polarity. Define double polarity in PAM. Double polarity PAM is a situation where the pulses are both positive and negative. That means this is the two cases. Positive minus. Two polarities we can show. There is double polarity. Whereas in previous single polarity means only positives. So positive, positive like that. No negative polarity. There is single polarity. Now what is uniform quantization? The type of quantization in which the quantization levels are uniformly spaced is termed as uniform quantization. Already we know that quantization means converting of continuous amplitude to discrete amplitude. So how this quantization is done? The quantizer which performs this quantization operation. So what this quantizer consists? The quantizer consists of a quantization levels are representation levels. So the representation levels are represented by L. And these representation levels are uniformly spaced. Then it can be called as uniform quantization. That means this is 0, this one, 1, 2, 3, minus 1, minus 2, minus 3. So these are the levels. So the levels are uniformly spaced. So we can take from 0 to 1, 1 volts. 1 to 2, again 1 volts. 2 to 3, 1 volts. So in negative side also same. So it is uniformly spaced. So the spacing between these two levels called as step size, delta. Okay, coming it will come. Define a signal. A signal is an electrical or electromagnetic current that is used for carrying data from one device or network to another. Simply, signal is an electromagnetic signal that carry information or data. Okay. What is multiplexing? The process of multiplexing divides a communication channel into several numbers of logical channels, allotting each one for a different message signal or data stream to be transferred. So there is the multiplexing. Simply you can call it as mux. Simply mux. It is divides a communication into several number of logical channels. It is this is mux, one to many, like that. Demux, extracting the number of channels from one which is done in the receiver, is called demultiplexing, the reverse operation of the multiplexing. So 1 to many, many to 1, many to 1. So that is a demux. Define companding. Companding refers to a technique for compressing and then expanding or decompressing an analog or digital signal. So here we know that where compressing is done and where expanding is done, and where compressing term will arise. Here quantization is a process of converting continuous amplitude to discrete amplitude, already we know, and these reference levels are uniformly spaced, then it can be called as uniform quantization, that will also know. Where non-uniform quantization is necessary, at that time we go for the compression. For example, we are going to convert a speech signal into digital one. So the speech having some low passages and some high passages, loud passages. High passages means loud passages. Some having weak signals. So my duty is to convert all this speech into digital one. Okay. So at that time, uniform quantization is not useful. Why? The step size is fixed. The levels are uniformly spaced. So when you can't catch the high or loud passages, and at the same time weak passages also. So for that application, we go for the non-uniform quantization. But non-uniform quantization is not available practically. So we are going to convert some process, that is uniform quantization. Before going to uniform quantization, we are going to compress the signal. Okay, so non-uniform quantization is equal to compression plus uniform quantization. So this is, you get the non-uniform. First you go to compress the signal and then apply this compresses signal to the uniform quantizer, then it acts as non-uniform quantization. So here we're having a compressor. So the compressor which is going to compress the signal. So where it is done? It is done at the transmitter. So the compression is done at the transmitter, and this compressed signal is going to quantize it, and then it is going to pass into the channel. After the receiver receives that one, then how much compression is done, then again is going to expand at the receiver. So that is expanding. So device which consists both compression and expression or expanding, that can be called as companding. That process can be called as companding, and the device which called as compander. So the compander which done companding. So companding is a technique for compression and expanding. Now what is a quad bit? A 16-bit PSK modulator acts on the incoming data in group of 4 bits is called quad bits. Quad means 4. Okay. Next, what is encoding? So encoding is the process of using various patterns of voltage or current levels to represent ones and zeros of the digital signals on the transmission link. Okay, encoding is the process of using various patterns of voltage or current levels to represent ones and zeros of the digital signals on the transmission link. Here, this can be called as signal representation, either ones and zeros signal representation. But encoding we can say in another way also. Encoding means here we are coding, so there is some secrecy we will maintain. Okay. What is decoding? Decoding is a reverse process of encoding, which is to extract the information from the converted format. So decoding is the reverse. So it is done at the receiver. Explain delta modulation. So type of modulation where the sampling rate is much higher and in which the step size of quantization is of smaller value delta. Such modulation is termed as a delta modulation. Here delta is the step size. Okay. So it is one of the digital modulation technique, digital modulation system. Delta modulation is the one of the digital modulation system. Now what is a PCM? PCM is a discrete time, discrete amplitude waveform coding process by means of which analog signal is directly represented by a sequence of coded pulses. Simply you can say PCM is a sequence of coded pulses. So here the analog signal is converted to digital in the form of coded pulses. So it represents coding and coding done on the pulses. So it is a sequence of coded pulses. So it is a discrete time, discrete amplitude. That means when the encoding is applied, when the signal is pure discrete form. Pure discrete form means both in time and amplitude it is discrete. Then we can apply the encoding process. Then it is converted into digital one. Okay. Define DPCM. This technique samples the analog signal and then quantizes the difference between the sampled value and its predicted value. This technique samples the analog signal and then quantizes the difference between the sample value and its predicted value. Here a predictor is there. So the predictor which predicts this differences. Okay. Define ADM, adaptive delta modulation. Adaptive delta modulation or continuously variable slope delta modulation is a modification of DM in which the step size is not fixed. In DM the step size is fixed, but adaptive is not fixed. So it is smart when it is operating or continuously varying the delta size. That means step size is varying continuously. That is adaptive delta modulation. Now what is quantization? The process of quantization replaces the true signal with approximation. That means quantization noise approximation. By increasing the number of quantization level, the quantization noise can be reduced. So here the quantization means the process of converting continuous amplitude to discrete amplitude. Okay. What is adaptive DPCM? Adaptive DPCM. DPCM is differential pulse code modulation. Adaptive differential pulse code modulation is used to decrease required bandwidth for given SNR. So here we are going to decrease the bandwidth. Why? PCM requires more bandwidth. So there is a drawback of PCM. So we are going to reduce that bandwidth. So we go for the adaptive DPCM. Define quadrature carrier multiplexing. Quadrature carrier multiplexing enables two DSB-SC modulated waves resulting from two different message signals to occupy the same transmission bandwidth, and two message signals can be separated at the receiver. So this is quadrature carrier multiplexing. Now differentiate match filter and correlation receiver. Why? Because here we are using to detect the signal. So at that time we must use this two, match filter and correlation receiver. So for coherent detection, one can use match filter or correlation receiver. Already we know that coherent detection. So others are not coherent. So only coherent detection. That is, we can use either match filter or correlation receiver. So where correlation is used, where match filter is used. Okay. So match filter is used when you have only one signal. So at that time we can use the match filter. But two signals of different frequencies, we go for the correlation receiver. So that is the difference between the match filter and the correlation receiver. Both are used for coherent detection, but here the difference is match filter is only one signal. Match filter is used only one signal, but correlation receiver is two of different frequencies. Okay. Now define aperture effect. Aperture effect is the effect due to which the higher frequency components of a signal are suppressed. Okay. Define aperture effect means aperture effect is the effect due to which the higher frequency components of a signal are suppressed. Define channel noise. So which is introduced anywhere between the transmitter output and the receiver input. The channel noise is always present once the equipment is switched on. So here they give clearly. Channel noise means anywhere between the transmitter output. So this is transmitter and this is the receiver. So from the transmitter to the receiver. So what do you hear? This is nothing but channel. So the noise which introduced at the channel can be called as channel noise. So channel noise is always present once the equipment is switched on, then easily adds to our signal. So whenever the signal adds with the noise, what happens? Errors will be raised. Okay. Now define quantization noise, which is introduced in the transmitter and is carried all the way along to the receiver output. Unlike the channel noise, quantization noise is signal dependent in the sense that it disappears when the message signal is switched off. Okay, when you switch off this message signal, then it is off. Means, so without message signal, there is no use of modulation or no communication. So quantization also always present along with channel noise. So quantization noise means we are going to convert in analog signal to digital signal. We are using quantizer. So the difference between the input to the quantized signal, that can be called as quantization noise. Okay. So two noises. One is the quantization noise, another the channel noise, always present. Now define slow power distortion. The step size delta is too small for the staircase approximation MQ of t to follow a steep segment of the message signal M of t, with the result MQ of t falls behind M of t. So for example, this is M of t. This is M of t. Here I am providing the staircase. So this is my M2 of t. So MQ of t must follow this M of t. If delta means this, the step size, is too small, then it fails to catches this message signal. So at this condition, this is called slow power load. This is called slow power load. Coming to the granular noise. Granular noise occurs when the step size delta is too large relative to the local slope characteristics of the message signal M of t, thereby causing the staircase approximation MQ of t to hunt around a relatively flat segment of M of t. So again, this analog signal. So this is called the granular noise. MQ of t is above the M of t. Okay, so it is called granular noise. So these two noises must reduce, either slow power load or granular noise. Define orthogonal vector. We said that two vectors are orthogonal if they are perpendicular to each other, that is the dot product of the two vectors is 0. So that is called orthogonal. Okay. Define signal space. The n-dimensional Euclidean space is called the signal space. In signal space diagrams, we can see this one, the n-dimensional Euclidean space. Okay. For development of this content, we use it for the Salman Hakim, Computer Systems by Salman Hakim, Jas Chitodi, and Sanjay Sharma. Okay, I hope you understand well. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.